Hello. All right. In this video, I'm going to do a problem with you so that you could use it as a reference. This particular problem is one sample, one proportion. One proportion hypothesis testing, hype testing. Okay, this is one of the things that you must remember. You need to know how to do. So please write good notes, all that, yada, yada, yada. All right, in order for you to do hypothesis testing, you need to do all these things. First, set up the hypothesis, check conditions. Let's just do one by one. All right, read this particular problem. One magazine says that 75% of the Korean population, they like having a pet. So you want to check it for yourself against a 5% alpha level. So which means that you want to test it. If it falls in the most extreme, so you randomly do one sample. If it falls in that most extreme 5%, you're going to doubt what the magazine is saying. All right, so so you set it up, right? And then you collect the data. You went out and randomly asked 150 people, 121 of them said they like pets. Okay, so null hypothesis, 75%. Alternative hypothesis is that you think that it's more than 75%. So we'll see if it's true. Okay, so the second thing is check conditions. So let's check our conditions. This is a proportion, so you need to have the three conditions for proportion. SRS is more than 10 times the sample size, 1,500. Make sure that it's greater than 10. 10 people times the sample size times the proportion is greater than 10, and then 1 minus p, all that stuff. Okay, that's finished. So done. So check. Set your alpha level. The alpha level is set to be 5%. That's what I did. Okay. So, well, this particular problem is like, okay, I should probably erase this 96. I just made that up. That's not true. Okay, so this problem is saying this. They're saying, all right, so we know based on the assumption, if it's 75, it's a normal distribution because all these things applied. And then the standard deviation of this is I'm not going to write it. It's over here, right? Kind of doing like a sampling distribution of n equals to 150. She's saying that, okay, you're going to do many of these, millions and millions of these. But if you randomly do one, okay, you do millions of these in your head. That's how this graph is formed. And then it's true. It will happen like this. I proved it to you before. And then, but if you randomly do one of these many billions, because you have a limited amount of time, you only did 150, one sample. And then that sample turned out to be 121 out of 150 out of these 1 billion. So is that one rare enough? If that one is more extreme than the most extreme 5%, at least this one is greater than, so we're only doing one tail. So this part has to be 5%. Then we're going to, so for example, if this one I calculated, it was roughly around 80.6%, right? We're going to say that, is this one within the top 5%? Because if it's the top 5%, we're going to reject the null. We define that as in it's too extreme. So maybe your original hypothesis is wrong. It's actually higher than 75%. That's what you're trying to test. Okay, so we do our math. Our original, the assumption is 0.75. And then your sample size is 0.806. I don't know where it is yet, so we'll check. Now, this one is the one that tricks students. You know the sample size is 150. So this one, are you supposed to do 0.75, 0.25, or 0.806 times 0.194? Which one? You need to know that it's based on your assumption. This graph is based on your assumption. So the standard deviation is based on your assumption, and then your assumption is 0.75, 0.25. It's very, very important. it will help you if you can just drill that into your head. Later, we're going to do other types of hypothesis testing, and then there are a bunch of variables you have to fill in. It's based on your assumption. That's a very, very important phrase that I hope you can keep telling yourself that. Okay, all right, so we calculate yada, yada, yada. That turns out to be 1.6. So that means that 0.806 is actually 1.6 standard deviations away from the mean, 0.75. Okay, so we actually have to calculate. We have to go to our z table to find where is 0.16. Sorry, 1.6. Okay, I'm not going to do it, but because I calculated already. So 0.16 is actually 0.16 over here. 0.16 is 94.52. So that means that occurs at least at a level that is, it could occur 94.5% of the time. Okay, so the z that we're checking for this particular value is 5.48. So it's over here. So over here is 5.48. 5.48. All right, as you could see, 5.48 falls outside of the value that we set for ourselves before. So that we're saying that, oh, so this case, this sample is not as extreme as the most extreme 5% cases out of these 1 billion cases. And then we say that because we set the alpha value at 5% before, we did all this math, and we say that, all right, so it's not extreme enough. This sample is not extreme enough for us to doubt the null hypothesis. So we're going to assume that this magazine was right. Okay? Because this value is greater than 0.05. So as long as it's greater than, you're going to accept. If it's less than, you're going to suggest alternative hypothesis. And remember, this is what you have to conclude. There is not enough evidence. There's not enough evidence to reject null. Okay, we're never going to say we accept null, but we're going to say we are not going to reject it. All right, that's it.